Welcome back to Python programming from beginner to programmer. So in this part of our discussion on data visualization, we mentioned that there are three sections that we will be discussing. First section is about Panda's set of chart and graph plotting functions and methods. And second section is on Seaborn. And this is the part that we will be expanding on. And the third section is on the use of Pillow library, PIL module, to operate on images and the pixels from a different perspective. So let's move into this segment's discussion using Seaborn library. Now, the way Seaborn library goes is that it is like pandas, it is, of course, able to operate on data frames and series. And it also is driving on top of matplotlib's pyplot module. So just like the plotting functions in pandas, Seaborn also is able to pass on, additional uh, parameter attributes that it cannot understand or it has no use of to the lower level where matplotlib and pyplot operates. So here, what we want to do with Seaborn is to understand essentially two categories of very nice plotting functions that Seaborn library provides. It provides a lot, just like pandas, but for introductory purposes, let's just be amazed and impressed by these two plotting functions. So they are basically heat map, okay, which is shown here on the top row, heat map and correlations. And the other very useful function is pair plot, okay, shown below here. So these two broad-based functions allow us to really see the relationships, all right, in a very visually impactful way. I won't say visually attractive. They look pretty, they look nice, but the main value that these functions provide, these charts provide, is that they will attract our attention, our eyeball apparatus, right? Our attention almost immediately when we fit them with proper colors and adjust them to proper scales. And then the important aspects of the data or sets of data immediately floats out, even if we are dealing with thousand sets of data and thousand rows of data. So here we again begin with a very simplistic data frame, but again, I like you to drive your imagination a little bit. We suppose we don't just have 4 columns, but we have 4,000 columns of data. Okay, we don't just have 7 rows of data, but we have 7,000 rows of data. Now at that level, 4,000 by 7,000, kind of a table size, it is no longer easy to just look at the numbers and determine what happens, especially when some columns or some rows interact. In other words, they present certain linear features like falling into lines of some sort, falling into a curve of some sort, falling into an S shape of some sort. Then it is no longer yeah, basically our eyes don't just can't make sense out of these numerical displays. So it is particularly with analyzing such huge sets of data, if you heard about big data, right? And we would like to detect any latent relationships. We suspect there are, but we're not sure which with which and exhibiting in what pattern. One way is to inspect like thousands and thousands of scatter plots. But again, by then we lose sight. So here, these two very powerful functions, heat map and pair plots, give us a very powerful, superior, wide scanning radar to quickly use our eyeball to capture any important aspects sort of residing deep within the data. Okay, so let's examine that a little bit further. All right, so let's look at heat maps. All right, heat maps. Heat maps, as the general understanding goes, is basically showing high or rich colors where the heat is, right? And showing cold colors where the temperature, so-called temperature, is not high. So if we interpret the data, where's the data? So the data here, right? So if you interpret these, like 8 is very high because it's like the max, right? Or 9 is the max along this column. And 0 is the most, it is the lowest value, right? In the whole data frame. So if we interpret these numbers as temperature, then what happens is that the heat map in Seaborn shows the cell with the highest temperature being like this brownish color, and the coldest cell having the lowest value as whitish here. Okay, so the darker the browner the color, the higher the value. So sometimes we are not so keen on finding the value, the absolute value itself, like 7 and 8. Maybe that's not much of a difference, something like that. But we are more interested in extremities. Then in that case, color maps or heat maps in this case really bring out all the important pixels and cells that make sense to us. So we know where are the cold cells, the low temperature cells, the zeros, the high temperature cells like these. This is high temperature. 9 is darker and browner than the 8, for example, right? So the heat map immediately shows that. And the XY layout, the x-axis, the column labels, the y-axis, the index labels. So if index happens to be date time, then this will be a date time. If index is a bunch of strings describing, for example, different brands of cars, then that would be basically different brands of cars. So they need not be ordered in the sense of 1 is greater than 2, 2 is greater than 1. Sorry, 1 is greater than 0, 2 is greater than 1, 3 is greater than 2. They need not be ordered. They can be categorical. They, of course, when they are ordered, such as if this is latitude and ABCD, they are longitude, like longitude values 100, 101, 102, then this actually will be a geometrical heat map. For example, showing crime rates, for example, showing dengue fever occurrence rates, COVID-19 occurrence rates, so as to see the potential spread or potential sensitive dangerous areas. So in essence, heat map tells a lot of stories and allow us to predict, essentially based very much on visual information. Okay, so after understanding why heat map is so great, how do we get it running? Now, all we need to do is to run sns.heatmap. Of course, we need to import Seaborn as SNS. So again, SNS, just like NP for NumPy and PD for pandas, SNS is standard usage for Seaborn. So sns.heatmap, all right? Send in the data frame. Obviously, it needs to know what is the data frame, and just sort of tell it what kind of heat map color you want, because it could be red for very hot, high values, and cold as in, or neutral as in pale color, but not white, and then cold, very cold as in dark blue, right? So that is also a heat map, but the two extremes, very red and very blue, are interesting to us. Here in this original heat map in common usage, the minimum is sort of like no transmission occurrence, no viral transmission occurrence area. So it's not interesting in that it is safe, right? We are okay, it's taken care of. And the high dark colored areas, the cells, represent somewhere where we are more interested in. So there can be only maximum are interesting, or only minimum are interesting, or only the extremas are interesting, maximum and minimum. So we need to pass in the color map, right? So the color map here, we don't fortunately need to list out every color. All right, we don't have to record and list out the color numbers one by one. We can, this is again where SNS comes in to be really, really handy, helpful. It can generate color palettes, right? It can generate color palette. A palette is like our watercolor palette, where we have those little sinks to make color. We can make various shades of colors, and that is exactly a color palette. So a color palette made up of yellow, orange, brown. So it's abbreviated as YLORBR. As CMAP equals to true. So just follow the convention. Check out the Seaborn documentation. But I'll just stick with this, right? Wouldn't want to spend too much time on adjusting the color unless that is really the core outcome of your investigation. So I just set up a color map CMAP and pipe it in. All right, again, this is a bit like our previous AX equals to AX. So this CMAP is the named parameter, and we want to pass to this named parameter our local variable CMAP here. We can call it CMAP1, CMAP2, and then use the same CMAP1, CMAP2 here. So this is our local variable. And this returns an AX just like df.blot. And then we just say that AX, that access set title to heat map like this.